Today we're going to review sketching quadratic equations, and in particular we're going to sketch equations that are in this particular form. Okay, y equals x minus 1, x minus 6. So this particular form is what's called intercept form, or sometimes it's called vertex form. And equations of this particular form are particularly nice because we've got these two separate factors in brackets, and that makes it actually very nice and very easy to find a lot of the critical points of the graph. When I approach a problem, or any sketching problem really, I'm always asking the same basic questions. Okay, I'm always asking, where are my different intercepts? So where are my y-intercepts? And usually, well, with any function there should be only one y-intercept. And I'm asking the question, where, if any, are my x-intercepts? And there may be more than one x-intercept, there might be no x-intercepts, but that's the question that I'm asking. The third question I ask, particularly with parabolas or quadratic equations, is where's the vertex located? Where's the turning point? So I want to know where these three things are. Those are the questions that I'm asking. If I can identify all of those, then I can easily sketch the graph. So when we're finding y-intercepts, we're always interested in the places where x equals 0. The reason for that is anywhere on the y-axis, okay, wherever this thing cuts the y-axis down here, it's going to have an x-coordinate of 0. They're going to be 0 something. Okay, I don't know what that something is yet, but for all of those things, the x-coordinate is 0. So that's the question that I ask. That's how I ask the equation, where are the y-intercepts. The same kind of logic applies for the x-intercepts. Okay, all of these places will have y-coordinates. There'll be something 0. Okay. So the question with the x-intercepts, when the x-intercepts appear, they'll appear when y equals 0. Now those two pieces of information, that the knowledge that y-intercepts happen when x equals 0 and x-intercepts happen when y equals 0, are the two of the most powerful bits of knowledge that we have when it comes to sketching equations. They're really important, and it's really crucial that you understand those bits of knowledge. So what I'm going to do now is I'm going to go through each of these questions, and then we're going to sketch the graph. So the y-intercept happens when x equals 0. So my equation was y equals x minus 1, x minus 6. I want to find y-intercepts. They happen when x equals 0. So what we do now is we substitute x equals 0 into the x's in the equation. So I get y equals 0 minus 1 times 0 minus 6. This is nice and easy to solve. 0 minus 1 is minus 1. 0 minus 6 is minus 6. Multiplying them together, I get 6. So that is going to be my y-intercept. Now we've got to ask the same question of my x-intercepts. Y equals x minus 1, x minus 6. I want to find x-intercepts. That means y has to be 0. So instead of making the x's into zeros here, I'm going to put 0 in for y. And I get 0 equals x minus 1, x minus 6. We'll rearrange this, and I get this. Now the temptation here is to expand this left hand side. Don't do that, because it actually makes your life a lot more difficult. At this point we want to apply what we call the null factor theorem, which is a fancy way of talking about a relatively simple thing. Okay? The null factor theorem just says that if I take two things, any two numbers, and I multiply them together and the answer is 0, then at least one of those two things has to be 0. Okay? So it doesn't matter what two numbers are, what I'm doing. If the answer to a multiplication is 0, one of the numbers that I'm multiplying must be 0. Okay, so that's what's going. That's relevant for this equation over here. I have two brackets which are multiplied together, and the answer is 0. So the logical conclusion from that is that either this one is 0 or this second one is 0. So either x minus 1 is 0 or x minus 6 is 0. And so if I solve these equations, I'm going to get that x equals 1 or x equals 6. And these will represent our two x-intercepts. So the two are 1 and 6. Okay. The final question that I had about this was the vertex. Now, with equations in intercept form, there's not really very many nice ways of finding the vertex. It's a little bit harder than the others. But what we can do is we can use the symmetry of the parabola. So something we know about parabolas is that they are symmetrical down their middle. So if I had some random point, in fact, let's have a go at just getting a rough sketch of what's going on here. My y-intercept's at 6, that looks about 6. My x-intercepts are at 1 and 6. Then my parabola is going to look a bit like this. It's not the greatest parabola I've ever sketched, but it's good enough for what we're doing. Okay, looks something like this. The vertex is always the turning point of the parabola, so this place just here. And the vertex has to be halfway between the two intercepts. Halfway between intercepts. Okay, and I've just found that my x-intercepts are 1 and 6. So we want to know, well, what's halfway between those two numbers? Okay. Now the best way to do that, if you're not sure, is just to average the two. So to average things, we add them up and divide by how many there are. Here we've got 1 plus 6. That's 7 divided by 2. 7 divided by 2 is 3.5. So that is going to be the x-coordinate of the vertex. Now, to get the y-coordinate, we need to substitute into the equation. So let's do that. When x equals 3.5, y equals x minus 1, x minus 6, not x, let's have another go there. 3.5 minus 1, 3.5 minus 6, then you get 2.5 times, oh, my scroll's going a bit funny there, what's that going to be? Minus 2.5. And I don't have a calculator handy, so I'm going to have to do this a different way. 2.5 is the same as 7 on 2. No, it's not. The same as 5 on 2. That's why you should always check. This is also 5 on 2. And multiplying that, I'm going to get negative 25 on 2, which is negative 12.5. So this, in fact, is going to dip all the way down to minus 12.5, and that is going to be the location of the vertex. And if we've done a sketch like this, that will be fine. Okay, we've shown our two intercepts, x-intercepts, we've shown our y-intercept, and we've shown the coordinates of the vertex.